So this is joint work together with Louis and Lars Mewes, both from Hanover. And it all emerged basically from a discussion we had at the Geography of Innovation conference in January, where we were discussing what can the network perspective, or how to apply or not to apply network perspective to knowledge spaces. Generally, of course, knowledge spaces, I assume, are well known to most of you, right? They are extremely fascinating, and thanks to efforts by many of the people in the audience, they're extremely fast diffusing and help us greatly in understanding the evolution of science, technology, and economic systems. So I guess most of us, if not all, have applied them more or less. Of course, we use this idea of knowledge spaces in a range of settings. So we apply them in order to describe technologies or relations between technologies. We also use them to infer about relations between industries or scientific disciplines. In the following couple of minutes of this presentation, I will always refer to knowledge spaces. However, the central ideas apply to whether you construct these knowledge spaces on the basis of technologies, industries, scientific disciplines. So it's a more general thing. So the knowledge space as such, of course, is used in order to quantify the degree of relatedness between sets of activities. Again, activities could be technologies, could be knowledge domains, can be industries or scientific disciplines for that matter. It is a kind of relational conception, so we're interested in the extent to which two activities are related to each other and how these relate to all the others. Usually they come in a kind of symmetric matrix. That is, we have a couple of activities for which each combination thereof we look at the level of relatedness. And here, as of now at least, I'm not worried so much about how we have estimated relatedness, whether it has been on the basis of labor flows or co-occurrences. We leave that aside for a moment. So we just have our measure of relatedness between any set of these two activities. We then usually don't just look at these matrices, although they're quite fascinating, but we use them in order to generate a couple of additional measures, for instance, relatedness density, or we really love to visualize them, right? That's one of the most fun parts, let's say, and that helps us greatly to diffuse this idea of knowledge spaces to an audience that might not be too familiar with the general with the underlying ideas. So, of course, when we visualize, these matrices are not really sexy to show to look at. So we usually use other means of presentation. Quite commonly, we transform these matrices into networks. Right? As soon as we have a positive entry in the matrix, we then assume this is a link. If we have no entry, meaning no relatedness has been calculated for two sets of activities, then this is we basically don't show a link. Right? An example can be seen at the bottom of the screen. We have our symmetric matrix on the left-hand side with our four activities, A, B, C, D. Certain degrees of relatedness depicted in the matrix that can be transformed into a network, right? And the network can be, or the matrix also can be either directed, that is, we might have a different level of relatedness between A and B than we have for B to A. Although I have to say, in most instances, we have symmetric matrices and a symmetric conception of relatedness, that is, relatedness between A and B is the same whether you look from the perspective of A or from the perspective of B. So when we transform these matrices into networks, we get these very, very nice, and of course we're still referring to this great work by Hidalgo et al. We get this wonderful visualization, network type of visualization of knowledge spaces. And that really helps us to explain where certain activities, knowledge domains, industries, technologies, and so on relate from a relatedness perspective to each other. So far so good. I think we are, most of us, I mean, I can scroll through the audience, but I guess most of those that have managed to join are able to have been doing this in one way or the other in the past. So why do we discuss this today? Well, there are three issues we believe that relate to the application of the knowledge space in some, not all, our work so far, and in particular also with respect to this transformation into networks. So we first will argue about that implicitly, at least, as soon as we present knowledge spaces as networks, or treat them as networks, we implicitly introduce a kind of flow perspective to knowledge spaces, and we'll discuss that in a second. Then I will talk about thresholds, visualizations, shortest paths. That are some concepts that need some clarification in this context. And lastly, but certainly not least, what is the issue with applying distance-based network measures to knowledge spaces? So let's start with the first issue, the knowledge space as a kind of network of flows. So most of us have started out from studying social networks, and here we have the idea, of course, that whatever diffuses in kind of social networks diffuses along those links that we observe empirically, right? So for instance, if we talk about knowledge networks between actors, and we have our four actors A, B, C, D, then we would assume that there's a high chance that knowledge will diffuse from A to B, and also from B to C, and so on and so forth, right? We usually also use kind of weighted knowledge networks. That is, we know that there are some links between actors that are more intense than others, and which consequently ease the flow of knowledge between the two. So in this context, I'll come back to this one. The conception of the shortest path also matters. So in the plot depicted here on the slide, we would assume that knowledge diffuses more likely from A to B, from B to C, and C to D than actually from A to D directly. Although there's a link, but as you can see, the value of that link is lower than, for instance, the combined value of the three links above. I'll talk about that later some more. The point I would like to make here today is, what is flowing actually in knowledge spaces? So what is this idea of something flowing in knowledge spaces that actually underlies the idea of applying type of network ideas to the knowledge space? So what I would like to say is that implicitly, we often make this assumption that there exists, or that there exist flows within the knowledge space, right? And if we do not make this assumption, then the question is actually, well, what is the meaning of indirect relations in this context? Why should we care about that one? So let me take a step back and look at the knowledge space as such, which usually represents a kind of aggregated, abstract or aggregated relational data of abstract entities, industries, technologies, and so on. So these entities are not social entities such as actors, individuals or firms or something like this. These are rather aggregated abstract entities we're talking about. So if we have this this understanding of the knowledge space, then the question is again, what flows between these abstract entities? So of course, if we talk enough about knowledge spaces, the first idea is that knowledge is flowing between these entities, right? If we talk about industries, then we would assume, for instance, that knowledge flows from A to B. For instance, if A represents biotechnology, B chemistry, then quite likely there will be a knowledge spillover from A to B, and from there from B to C, and from C to D, right? And D being, for instance, advanced materials. So the idea, if we have this perception and if we believe in this idea of that indirect relations matter in this conception of knowledge spaces, then we will argue that if we look at the graph again, that the knowledge that is diffusing in this knowledge space is more likely to diffuse from A to B and from B to C and from C to D than again directly from A to D. The question is, or if we talk about diversification for that matter, right? it means basically that it's more likely that A and B will establish a combined, will be combined in one way or the other than A and D, which seems to be quite reasonable. But we also assume that it's more likely that A and B and C actually combine their knowledge in one way or the other than A and D. So usually, and the nice thing is if you don't have slides in presenters mode, you can add and correct small mistakes immediately. The idea is, of course, if we have this knowledge flow perspective, we have to assume that the knowledge space actually represents some kind of social interaction patterns. So we make the assumption that the more intense or the higher likelihood of knowledge diffusing from A to B than from A to D is due to more intensive social interactions, because we know that knowledge can only diffuse by means of social interactions, right? So we actually assume that the interactions between A and B are more intense than between A and D, between B and C are larger than, again, A and D, and so on and so forth. But if we apply this idea, then it actually means that the knowledge space becomes an approximation of social network structures, right? So we assume that, at least in an aggregated sense, the knowledge space represents social networks or the structures of underlying social networks. But this is really something that we believe in, right? Because it would also imply, if the knowledge space is solely based on, or is constructed on the basis of relatedness or technological distance for that matter, it means that technological distance is the only or the primary driver of the underlying social networks, because only then we can say, okay, the structures that we observe on the basis of that we observe in the technological relatedness information represent social networks only to the extent that the social networks are actually shaped by this technological distance. But of course, we do know that there are a lot of more information or a lot more factors that influence the likelihood and intensity of social interactions. And we ignore that because we're only saying, okay, if we assume this knowledge flowing, this greater likelihood of knowledge flowing alongside related activities as represented in the knowledge space, then we make the assumption that if this represents social underlying social structures, these social structures are correlated or even shaped exclusively by technological distance. And of course, this is at odds with everything we have elaborated in the literature on the formation of social networks, where of course technological distance plays a very important role, but by no means the only role. So as for instance, geographic distance also plays a role. So we cannot directly say that, okay, the knowledge space is a kind of revealed social interaction or social structure measure in that sense. So then the question is, okay, do we really need to have this flow assumption in the knowledge space, right? Do we need to believe that, you should always turn off your phone, do we really need to believe that knowledge is flowing in this graph from A to B and B to C and C to D, that this relationship is more likely that the knowledge of A flows to D than the direct link from A to D? Well, if we don't make this assumption that these flows take place, then the question is, what is the information content of indirect relations in the knowledge space, right? What is it of value to us that we know that B and C are related at a level of 0.6 if we look at the relationship of from A to B and A to D, right? So also we may question, if we don't make this flow perspective, what is the point of the entire network visualizations, right? Network visualizations live primarily not from showing direct links between nodes, but in particular from showing indirect relations, that is, how nodes relate through passes that do not involve the focal nodes themselves. So that's the first point I want to make. I'll come back in the conclusion a little bit on that one. The second point I would like to make is, okay, even if we assume we can live with this flow perspective and we can make this assumption, there are a couple of things we have to watch out for. The first represents thresholds, visualizations, and shortest paths. When we present knowledge spaces in publications and presentations and so on and so forth, we don't present, as I mentioned before, the original symmetric matrix, because this is not really fun to look at, but we rather manipulate this information in certain ways to make it visually more appealing. For instance, we normalize relations by means of statistical cutoffs, right? We make this differentiation between relatedness values that are, let's say, significant and those that are insignificant, or that are above a certain threshold and that are below a certain threshold. We do this for visualization purposes. However, we also do this, and I will come back to this one in my last point, we also, or some of us at least, or some researchers, let's say, do this also before applying certain measures to knowledge spaces. So we don't look at the pure co-occurrence, let's say, or the original labor flows between industries, but we treat them in order to separate, let's say, statistical noise from these type of relations. In any case, there's not a perfect method of doing that. And quite frankly, in particular, when it comes to visualizations, and I'm guilty as charged, we use a kind of arbitrary elimination of weaker relations. So we say this is a certain cutoff. We eliminate that because then the visualizations become more appealing. The knowledge space looks more beautiful, or we can recognize certain structures more easily. In particular, and this is also something that is inspired by Hidalgo's work, we like to apply this kind of maximum spanning tree ideas. That is, we look at the least number of links that connect all the nodes, and in that case was products, so that we don't have any isolates. And we add then, in order to make it visually more appealing, certain numbers of additional links, such that we have a nice picture in the end. The positioning of nodes in these network representations is done in order to maximize visibility, right? Fruchterman-Reingold mechanisms or other type of force-based mechanisms are used to create these wonderful plots. So I would like you to take a look at these two plots, which represent more or less the same type of information. On the left-hand side, we see the full knowledge space, that is, no relations have been deemed insignificant, no relations have been removed. We basically consider all links, valued links between, in this case, industries, right? We have certain industries here represented as nodes, the level of relatedness based on labor flows between them. And we see certain structures. For instance, we see that in the full knowledge space, without any manipulations, we see that hotels and restaurants appear to be relatively closely related to each other because they are positioned in proximity to each other in this plot. Right? So if we would advise policymakers, we would say, well, there we have a kind of cluster of related industries. However, what we then tend to do is, for instance, we say, well, let's eliminate a couple of relations in this knowledge space to make it clearer, right? We have too many links in there. We don't really see a clear core of the knowledge space. So let's do certain kinds of visualization, of adaptations or modifications. We have done that. You can see the result on the right-hand side. And what emerges here then is how this impacts the positioning and at least the visual impression we get from the knowledge space. All of a sudden, the knowledge space becomes much more centralized, right? We see now all these light blue dots in the center of the network, and we see a couple of industries that are rather located in the periphery. And look what happened to restaurants and hotels. Two industries which, on the basis of the full knowledge space, we perceive to be rather related because they were more or less co-located in this plot, find themselves now on complete different ends of the knowledge space. right? And now we might be tempted to argue, well, in order to diversify, let's say, from hotels to restaurants, we have to go first to the center of this knowledge space through the, I'm just guessing now because I can't see it that clearly, through the light brown and light blue dots in order to diversify eventually into restaurants. While in the full knowledge space picture, we would get a totally different impression, and we would actually say, well, maybe it's quite there's a quite direct link between these two industries, making diversification relatively simple. So this is one of the dangers that we I think have to be aware of when applying these visualization enhancing modifications, because they change and alter the underlying information. One may argue, well, they extract the core features, but of course, as there is a lot of, let's say, arbitrary choice in between, I'm not entirely sure whether we can always rely on that. So we are in the danger of making some kind of biased conclusions on the basis of visualizations. I assume most of us actually don't draw, let's say, policy recommendations from these type of visualizations, because I hope so that most of us are very much aware of these limitations. However, what we also have to consider is what happens to, let's say, our work when we're not around, right? Once we have shown these type of visualizations to policymakers, once we have passed on our slides with these type of network plots to policymakers, can we really be sure that they will be aware of the limitations of these plots, even if we have told them though beforehand? Yeah. So, and this particularly relates to the distance between nodes that kind of serves as an indication, at least a visual indication of relatedness structures or possibilities of diversification and so on and so forth. Right, so this information reduction, which we do, well, with the right intentions to extract the main structures, to make it visually more appealing, to highlight certain information, actually bears a lot of danger because it alters the structure of the knowledge space and what we can get from that, right? And in particular, if you think along those lines, the definition of cutoffs and thresholds does not only change the positioning of nodes, but also to what extent nodes are perceived to act as bridges or gaps between different industries. Yeah. Of course, if you think then longer, and I'll come back to that one, the last point, this may also impact certain measures we are generating. So if we apply measures on the basis of knowledge spaces that have been somehow manipulated by eliminating insignificant relations, excluding certain relations for whatever reasons, our measures that are based on these knowledge spaces might also be biased or at least impacted by those type of things, right? So in particular, what we discuss in this paper is that if you think about the idea of shortest paths, which are an essential feature of networks because it indicates a kind of probability that whatever diffuses, whatever happens in the network, happens along these shortest paths and not any other one. This really changes something. And I've talked about this a little bit before. This is the same network plot where I just plotted the two or represent the two shortest paths we observe. The relationship between A and D is in the focus here. And if we look at the, let's say, the full relatedness information, we see that the relatedness between A and B is given by 0.8 and so on and so forth, meaning that the indirect path between A and B obtains a value of 0.288. What we, however, have observed and deleted was the original relatedness of 0.2, right? So now we may argue, yes, it's correct that we have eliminated this direct link of with a value of 0.2. However, we keep this type of indirect relations with a value of 0.288 in our estimations and in our considerations, which is, if you really think about it, not that much different. And of course, it would have been easy to adopt these numbers such that actually the indirect path would have had a lower value than the direct part, which we have originally cut off. So the point here is that we would make, in this case, inference, interpretations, calculations based on this indirect path, which may or may not be, in sum, have a lower value or a very similar value to the direct path which we have previously eliminated. So there's a lot of potential of over and underestimations. Coming to the last point, which is the kind of culmination of all these issues, if we work with these type of cutoff values, and again, they might be the idea for cutting certain relations from the original relatedness matrix might be done in good purpose, right? We might say we would like to extract random random relatedness relations from this matrix. The point is, of course, if we apply even more sophisticated measures of to correct relatedness for the potential presence of statistical noise, we can only say that a relationship might not, or we are not able to differentiate a relationship with respect to whether it is random or not random. Of course, there's no exact test that tells us this relationship is really random. We can only say, well, we cannot really differentiate whether it's random or systematic. And still we eliminate these type of information from the relatedness matrix and from the type of knowledge space visualization and network conception. And this is, of course, a huge problem when we apply social network measures. I already pointed to that one, because network structures are really sensitive. So they may change dramatically when we cut off a very particular link, right? We all know, think about a fragmented network consisting of two different parts, and then all of a sudden we add one link that connects these two parts. Our network measures, in particular those that represent global network statistics, change completely in that minute, right? As soon as we have this additional link. Of course, the same happens when we remove this link, because, well, we think we cannot really say whether this link is due to a random data or observation of a random relationship, or whether it's really systematic. In particular, what changes from a network perspective when we delete links or when we remove certain links is that the distance matrix, so the underlying distance matrix of the network that gives us the number of steps, if we talk about unweighted networks, the number of steps between two not direct, or between any pairs of nodes. So that is two directly related, two directly linked nodes have a distance of 1. Nodes that are distance 2, of course, have another node in between, and so on and so forth. So this distance matrix that gives an idea about how far away any pair of points are, or nodes are from each other in the network changes dramatically if we remove certain links. And in consequence, all the measures that heavily rely on this distance matrix, and I'm talking primarily about betweenness, which is very, very common for us to apply, because it gives us an idea of how central technologies, industries, whatever, are in a knowledge space, or closeness similarly in that respect. They may change dramatically by excluding or including a specific link in the network. In contrast, local network measures, for instance, degree centrality, in particular, if we talk about weighted networks, there it's unlikely that they change dramatically if we remove somewhere in the network one link, because one link usually then impacts only the two nodes that are directly involved in this link. And this is the good news in terms of relatedness density, for instance, which is a kind of weighted degree centrality. So that will be less impacted by this matter. However, we don't really know to what extent it may nevertheless be impacted. So if we believe in these three issues, if we say, well, yeah, it's a good point, what do flows actually mean in knowledge spaces? What does this flow perspective add to the idea of knowledge spaces? And again, as soon as we drop this assumption that something is flowing in this knowledge space network, let's say, then it doesn't really make sense to apply a network visualization or apply distance-based social networks measure on that basis. So that's the first issue we have to clarify. Then, of course, there's the issue of thresholds, visualizations that may alter what we get from it, and in particular, the application of distance-based networks matters. So what is the solution? And of course, one should always close with a kind of solution. Well, the first one is we should think about whether it really pays off to present knowledge spaces as networks. Again, even if we as ourselves, and we are knowledgeable about these type of things, are cautious about these network visualizations and know that they have limitations, well, others might not be that informed about it. So therefore, we rather say, and this is something which you find also in the original publication by Hidalgo et al., present knowledge spaces as heat maps. Right, so on the left-hand side, I really have to apologize. Louis provided me with higher definition images last night, and I didn't really include them in this presentation. Sorry. So there are better pictures available, at least in the paper for sure. So we see this type of relatedness matrix here represented as a heat map. This represents relatedness between industries in Norway. The different colors on the left-hand side on the on the columns and rows represent the different overarching sectors, let's say. And we can see that at least relatedness within these sectors tends to be greater than between different types of sectors. Of course, if you look at the very, let's say, aggregate way, this density map on the left-hand side, which shows all the sectors, this might not be as informative. However, of course, we can always zoom into these heat maps and really extract more information from that one. Yes, and there are a lot of different procedures that allow us also to rearrange heat maps, to cluster observations therein, and to get more or less the same type of information that we would have by using the network perspective. The main difference being, though, is that we don't have to eliminate any type of links in there. And we also do not induce this impression of indirect relations being of relevance here, right? Because every relationship that is in there, every direct relationship will be represented and will be used in, for instance, clustering algorithms. The other thing I think we have to work on, in particular theoretically, is what is the meaning and the usefulness of this flow idea in knowledge spaces. Right? As I hopefully pointed out sufficiently, this flow assumption is quite essential for what we do with this type of knowledge spaces. And in particular, it concerns the relevance and importance of indirect relations. So we have to clarify, what does it mean? Maybe there are good and valid reasons to make this assumption. Maybe it's a good assumption and a true assumption. Then most of what I've been talking about would not be an issue. But as of now, and at least with respect to my knowledge, I haven't seen much discussion on that one. Another habit we have, and I'm guilty as charged, we have adopted is the binarization of relatedness. So we like to classify relations as being significantly related, or industries or knowledge domains, whatever, being significantly related or not significantly related. And I think this is, and Louis has almost completed a paper on that matter. This is a huge thing, but the question is, do we really need that? As I showed in the presentation, it might change our inspection, our impression we get from knowledge spaces. It impacts dramatically some of the measures we are applying. And this is something we have to question whether it's really worthwhile doing. Generally, I suggest to don't apply global measures of social network analysis on reduced knowledge spaces. This is in particular true for measures that somehow represent or that somehow consider indirect relations, that is a distance matrix of networks, in particular between the centrality, in particular closeness centrality, and so on and so forth. Those will be or are strongly impacted by the binarization or by the removal of insignificant relations, whatever those may be. And here we really have to work on and think about whether this is really worthwhile doing, because all of these measures will also work on the empirically observed, unchanged, unmodified information we have in the original co-occurrence matrix or flow matrix, how you want to call it. So do we really need and should engage in all the manipulation thereof, or not just work with the true and directly observed data? And this is all I wanted to say today. So then the question is, thank you for your attention. Usually I close with this slide. Are there any questions or comments? And the idea is that we have written a short paper, which we have shared